In this video, I'm going to cover the very first topic of A-levels chemistry, which is about atomic structure, and specifically about topic 1.1, which is about particles in the atom and atomic radius. So first and foremost, description of an atom. How do you describe what an atom is? Now, you can see a very simple diagram of a neon atom on the left side. So an atom is mostly it's empty spaced, and we have a very dense nucleus at the center. And this center is composed of what we call protons and neutrons. And protons and neutrons can also be called nucleons together. And electrons are found in shells at different energy levels around the nucleus. Subatomic particles. We already learned that there are three particles that exist in an atom, which is protons, neutrons, and electrons. Those are called subatomic particles. You've probably learned this in IGCSE, but you still need this knowledge. Proton has a relative mass of 1 and a relative charge of positive 1. Neutrons has a relative mass of 1 and it has no charge, it's neutral. And electrons are the lightest subatomic particle, which you can see it's very small and it has a relative charge of -1. So meaning that if an atom is neutral, the number of protons has to be equal to the number of electrons. And that's how an atom is neutral. Since the mass of the electron is so small, it's negligible, and it would make sense to you that when we're talking about the mass number or the mass of an atom in the future, you should know that that mass depends on proton numbers and neutron numbers. Let's learn how to work out the number of protons and neutrons. There are two words or terminologies that you need to be familiar with before we talk about this. The first of which is called the atomic number. The atomic number means the number of protons in the nucleus of an atom. It means how many protons are there. So the atomic number will be equals to the number of protons, and that is why sometimes it will be also called as the proton number. And again, the number of protons do not change during chemical reactions. Only electrons are transferred or shared. That's why we can say that an atomic number will define what element we have or what atom do we have. For example, if an atom has 9 protons, it means that that element is always going to be fluorine. Now, the next terminology that you need to be familiar with is called the mass number. The mass number is the sum of the number of protons and neutrons in the nucleus of an atom. So if you were asked to calculate the mass number, it would mean the number of protons plus the number of neutrons. And we already learned this terminology called nucleon, and sometimes it will also be called as the nucleon number. Now, that being said, let's go and do a few exercises on this one. Now, let's say you see a description like this, and you're asked to find the number of protons, neutrons, electrons, atomic number, and mass number. How do you work this out? First, you need to know that the smaller number is always going to be the proton number. Because why? The larger number, which is the mass number, is the sum of proton plus neutron. And that's why the number of protons now would be 9 here, and the number of neutrons would be 19 minus 9, which gives us 10. Now, the number of electrons, and this is not an ion, this is a neutral atom, so it means that the number of protons would be equal to the number of electrons. Now, the atomic number is the number of protons, or the proton number, so this will be 9, and the mass number will be the sum of protons plus neutrons, so it would be 9 plus 10 equals to 19, which you can already see from here as well. Now, students tend to get a little bit more confused when it comes to ions, where it has either more electron or less electron. Now we have a sulfide ion here with a charge of S2 minus. Now how do we work this out? Notice that you're not given a proton number in this case. You can go and take a look at your periodic table to see what the proton number is. So you'll see 16 and 32, and proton number is the smaller number, so the number of protons is going to be 16. Now, the number of neutrons would be your mass number minus your proton number, so it would be 32 minus 16, which would also give you 16 as well. Now, the number of electrons, this is where you have to be a little bit careful. Because it's a negative ion, it has 2 more electrons. Because why? It's 2 minus here. It has 2 more electrons than a neutral atom. A neutral atom would have 16 electrons. Now, because there are 2 extra electrons, this would be 18 electrons. The atomic number is still going to be the same, which is just 16, and the mass number is still going to be 32. Now, for a positive ion such as Ca2 plus or a calcium ion, take your time to walk through this. The number of protons can be looked at from the periodic table, which is 20, the smaller number. The number of neutrons would be your mass number minus your number of protons, which would also give you 20. The number of electrons, see, because it's Ca2 plus, this positive ion is formed by losing 2 electrons, and that's why it's going to be 20 minus 2, which is 18. This 20 is what a neutral atom would have had. The atomic number is equal to the proton number, which is 20, and the mass number is still going to be 40. Now we're going to learn about another terminology which is going to be new to you, which is called the atomic radius. Now, the atomic radius defines what the size of an atom is, and it's the half the distance between 2 nuclei of covalently bonded atom. Let's say we have a hydrogen molecule here. What's the atomic radius then? It's the distance between 2 nuclei, and let's assume this to be d, and the atomic radius r would be d divided by 2. There is no need for you to know how to calculate this, but that being said, you need to learn about the trends of atomic radius. When you're going across the period, does it become bigger or does it become smaller? So the first thing is we're going to learn about atomic radius going across the period. Now there are 3 elements that are in the same period: lithium, beryllium, and boron here. And as you see, in the same period, as you go from left to right across the period, the number of protons has increased, right? Because it was plus 3 here, and it's 4 here, and it's 5 here. Now, the number of protons is also called the positive nuclear charge. Why? Because in the nucleus, the only particle that has a charge is protons. So it would make sense that this has plus 3, plus 4, and plus 5. However, as we go across the period, the number of electrons also increase. But these electrons, these extra electrons are still added to the same principal quantum shell, or for now you can just stick to same electron shell here, which is the second shell. There's no need for you to know this yet. I'll cover this in a different video. Now, although the electrons are still being added to the same shell, the positive nuclear charges increase, which means that we have a larger nuclear charge, and it's gonna have a very large pull on the nuclei of the electrons here. And that is also why the atomic radii will decrease as you go across the period. When you're going down the group, in this case, it's group 1, which is lithium, sodium, and potassium. Going down the group, you'll be able to see that the number of electron shells has increased. Lithium has 3 electrons, so it would make it 2.1, and sodium is 11, so it would be 2.8.1, and potassium would be 19, which would make it 2.8.8.1. So you see that as you go down the group, you have an addition of electron shells. And what will happen in that case is when you have more electron shells between your positive nuclear charge and the outermost electron, the electrons in the inner shells, because they're all like charge or same charge, they're going to have what we call repulsion. And this repulsion of the inner shell electrons is going to shield this outermost shell electron from being pulled by the positive nuclear charge. And what it does is that it weakens the pull of the nuclei on the outermost electron. And that is also why, as you go down the group, the atomic radii will increase. Talking about trends in ionic radii cannot be done unless we understand what's the difference between positive and negative ions in terms of their radius. Now, on the left side, you can see a neutral sodium atom. And for a sodium atom to become a sodium ion, it loses 1 electron from the outermost shell, and now it has 2 shells with a positive charge. So positive ions are formed by losing electrons. However, you see that the positive nuclear charge, it remains the same. But now we have fewer electrons. It means that the pull from the nuclei, or the electrostatic attraction between the nucleus and the electrons, is going to be stronger on the remaining electrons. And that's also why a positive ion is going to be smaller than a neutral atom. So how about neutral atoms against the negative ions? On the left side, we have a neutral chlorine atom here. And on the right side, because the chlorine atom has gained an extra electron, it's going to have a negative charge. So which one is going to be larger? So the negative ions are formed by gaining electrons. However, their positive nuclear charge will remain the same. And because of the addition of the electron and the shielding itself, the outermost electrons are going to be further away from the nucleus. And that's why the pull from the nuclei, or the electrostatic attraction, is going to become weaker with more electrons. It means that negative ions are going to be bigger than the neutral atoms. What we have discussed so far, the ionic radius and the atomic radius, can be summarized as follows. I'll go over the atomic radius first. So as you go from left to right across the period, it's going to get smaller. But as you go down the group, the atomic radius is going to become bigger with addition of electron shells. For ionic radius, the general trend is that going from left to right, it's going to become smaller. But you can't say that without talking about this area here. So the positive ions, so boron 3+ will definitely be stronger than Li+. But when we get to the part with negative ions, O2-, because it's negative ion, is going to be larger than boron 3+ positive ion. And from that point onwards, it's going to get smaller, right? And ionic radius is the same as atomic radius in terms of going down the group. The size of the positive ions or the size of the negative ions will become bigger and bigger as you go down the group because of addition of electron shells.